All right, so in this video, we are going to be solving trig equations between 0 and 2 pi. We're basically getting all the solutions between 0 and 2 pi. Usually, I have two solutions between 0 and 2 pi, but now I have a k value of 4 in this question, which means I'm going to have 8 solutions between 0 and 2 pi. So you want to start with your cast rule over here. I know sine is positive in my first two quadrants. So I'll do the sine inverse of root 3 over 2. And I basically get my first solution in my acute angle as pi over 3. But this is not an actual solution because now we're going to have 4x equals pi over 3, which is the solution for this quadrant. And the solution for the second quadrant is pi minus pi over 3, which is basically 2 pi over 3. So I have 4x equals 2 pi over 3. Now, in order to find my first two solutions, I've got to divide by 4 on these two sides. So in this case, x is pi over 12. And here, x will be pi over 6. So these are my first two solutions. Now I'm going to show you how to get the remaining 6 solutions over here. I know that my k value is 4, which means that my period is 2 pi over 4, which is basically pi over 2. So all I have to do is add my period to these values multiple times, and I'll get all my solutions. I'll start with this one over here. So pi over 12 plus pi over 2. My second solution is just 7 pi over 12. I'll add another pi over 2 to this. That's 13 pi over 12. And I'll add another pi over 2 to this, which is just 19 pi over 12. So those are my first 4 solutions for my first one. I'm going to do the same thing with this one. I'm going to take pi over 6, and I'm going to add my period, which is pi over 2. My second solution is 2 pi over 3. I'll add another pi over 2 to that. My third solution is 7 pi over 6, and I'll add another pi over 2 to this. My final solution is 5 pi over 3. So these are my 8 solutions between 0 and 2 pi for this question. Let's go to the second question. In the second question, I have sec of 3 times beta equals to 2. So anytime I have a reciprocal, I want to convert my reciprocal to my original first. So cos 3 beta just equals to 1 over 2. I flipped this side upside down. I know I'm going to have a total of 6 solutions over here. I'm going to start with my cast rule. I know cos is positive in these two quadrants. And then I'll do the cos inverse of 1 over 2. And I get pi over 3 as my acute angles. And my first solution, 3 beta, is going to equal to pi over 3. The second solution is 2 pi minus pi over 3. So 3 beta equals 5 pi over 3. Now I can divide by 3 for both of these. So my first actual solution is pi over 9, and my second actual solution is 5 pi over 9. So now I just need to find 2 more solutions for these, and I'll have my 6 solutions total. In order to do that, I know I have to find my period. So k just equals to 3 in this question, which means my period is 2 pi over 3. All I have to do is add 2 pi over 3 to these two values twice to get my next couple of solutions. So I'll start with the pi over 9. I'll add 2 pi over 3 to it. I get 7 pi over 9 as my second solution. And as my third solution, I just added another 2 pi over 3. I'll get 13 pi over 9. I'll do the same thing here. 5 pi over 9 plus 2 pi over 3 is just 11 pi over 9. And I'll add another 2 pi over 3, and I get 17 pi over 9. And if you notice, these answers are all less than 2 pi. Let's go to the third question. The third question is just two cos 2 theta minus root 3 equals to 0. So I just want to start by isolating my cos term in this question. So I'm going to start with moving the root 3 to the other side, and then I'm going to divide by 2. So cos 2 theta equals to root 3 over 2. Now it's just the same as the first two questions. I'm going to do my cast rule. I know cos is positive in these two quadrants. I'll do the cos inverse of root 3 over 2. Which is just pi over 6. So I know that I'm going to have 4 solutions in total here because it's a 2 theta. So 2 theta equals to pi over 6, and 2 theta equals 2 pi minus pi over 6 is just 11 pi over 6. Next, I'll find my period. My k value is 2, which means my period is 2 pi over 2, which is just pi. So all I have to do is add pi to these two values. Oh, wait, I got to divide by 2 first. Forgot to do that. So I'll start by dividing by 2, which is pi over 12 and 11 pi over 12. And then I'll add pi to these two values. So this is going to become 13 pi over 12. And this is going to become 23 pi over 12. And these are my 4 solutions in this question. Okay, let's go to the fourth question. 3, I guess root 3 tan t over 3 equals to 1. So now we notice that our k value is actually a fraction. This is going to create a horizontal stretch. It's actually impossible to predict how many solutions you'll have here. You might have 1 solution or 2 solutions, sometimes even no solutions if the stretch is really, really, really big. But the only way to find out is to actually solve the question and then evaluate your final solutions. So I'm going to start by isolating the tan here. So tan t over 3 equals 1 over root 3. Then I will do my cast rule next. So I know tan is positive in these two quadrants. I'll do the tan inverse of 1 over root 3. And I just get pi over 6 as my acute angle. And then over here, I know that t over 3 equals to my first solution, which is pi over 6. And t over 3 equals to my second solution, which is pi plus pi over 6. That's 7 pi over 6. Now, all I have to do is cross multiply the 3 to the other side. So if I cross multiply the 3 with pi over 6, I'll get pi over 2. And over here, if I cross multiply, I will get 7 pi over 6 times 3 is 7 pi over 2. Now let's evaluate these two solutions. So pi over 2 is definitely smaller than 2 pi. But 7 pi over 2 is much larger than 2 pi. So this is an invalid solution. And we actually have only one valid solution in this question, which is pi over 2. Last question we will do is sine of x over 2 equals root 2 over 2. Or maybe we'll actually do 2 more questions. I see another one too. So we'll probably do 2 more questions. I see another one that's a really good one to do as well. So I want to start this with my cast rule over here. I know sine is positive in these 2 quadrants. So I'm going to do the sine inverse of root 2 over 2. Which is pi over 4 as my acute angle. So I know that my 2 solutions are going to be x over 2 equals pi over 4. That's my first solution here. My second solution is going to be pi minus pi over 4. So x over 2 equals 3 pi over 4. I'm going to cross multiply the 2 to the other side. So I get x equals pi over 2. And here I'll get x equals 3 pi over 2. And what you notice in this question is these are both less than 2 pi. So they're both valid solutions. So in this case, both these solutions are good. All right, let's try another question. This is going to be the last one in this worksheet. It's going to be very similar to the last one, just slightly more difficult. So sine x over 2 equals negative root 2 over 2. So almost identical. The only difference is the negative. Again, we will start with our cast rule. Sine is negative in these 2 quadrants. If I do the sine inverse of negative root 2 over 2 in my calculator, I will get pi over 4 as my acute angle. So I know that x over 2 equals, my first solution is pi plus pi over 4, which is 3 pi over 4. And my second solution, x over 2, 2 pi minus pi over 4 is 7 pi over 4. I'll cross multiply the 2's to the other side. So I get x equals 3 pi over 2. And here I get x equals 7 pi over 2. Again, 7 pi over 2 is too big to fit in this. So this is not a good solution. It's invalid. We only have one good solution in this question, which is 3 pi over 2. Okay, so what do you notice when comparing these 2 questions? Even though they're so similar, one of them may have 2 solutions. The other one may have just one solution. And if you want to take it a step even further, I can actually explain an even harder one. Let's compare this one to this one right here. Going to have sine of x over 4 equals negative root 2 over 2. So I've just changed the k value a bit in this one. And if you evaluate this one, the steps are all the same quadrants, same acute angle, same solutions. So x over 4 equals 3 pi over 4, and x over 4 equals 7 pi over 4. But now when we cross multiply, guess what happens? This is going to become 3 pi, and this is going to become 7 pi. And if you look at these 2 solutions, they're both bigger than 2 pi, which means they're both invalid, which means there are actually no solutions in this question.